Welcome to the ISC Think Tank series hosted by HPC Wire. This is a new format produced by ISC Events and HPC Wire to establish a meeting of the minds between the HPC thought leaders. So basically, gentlemen, you are intended to be the thought leaders here. The topic this year is the realities and challenges of HPC in the cloud, and we are interested in your opinion on this. The panelists today are Josh Simons, HPC architect at VMware, Dan Reed, Corporate Vice President of Technology Policy and Strategy at Microsoft, and Christian Tănăsescu, Vice President Software Engineering at SGI. If we talk about clouds today, we know that cloud adoption is one of the major topics of interest, and we hear many people talking about it. Business and industry are jumping on the cloud train. However, there seems to be one group of people who are not jumping as much as the others do. That's the HPC community. And I would like to start with a question: what are the major roadblocks for HPC on the cloud? What are your opinions on this topic?
Sure, Dieter. So I guess I would start with some of the basic technical concerns that the HPC community has. So for example, performance issues. How well does my workload run in a cloud environment on a virtualized platform? How can I get my data into a cloud, especially if I have large volumes of data? And those sorts of questions, I think, cause people perhaps some questioning about how appropriate a cloud environment is for HPC. I think we have answers for some of those, and those are evolving over time, but those are certainly questions that people have.
Mm-hmm. Dan, what is your first answer?
So I would agree with that. I think there are technical issues to be resolved around interconnects and performance and scheduling issues. But I think, like all of the technology transitions that we've seen, if we looked at the transition to clusters a decade or so ago, many of these issues are cultural. It's about engaging people to think about how the technology enables some things, but requires all of us who both build services and the folks who build applications and use them to think about how they also move to meet the technology in the middle.
Christian.
Yeah, I agree with Joshua and Dan said. I would also add maybe one other perceived roadblock, which would be software licensing. So one of the main use cases for cloud is to lower the barrier to technology, right? And in particular for small companies, the main applications they use in their business, daily business, is coming from ISVs or commercial applications. And there, the ISVs, I believe, are not yet ready. I'm not speaking for all of them, but most of them are not ready to move the business from the annual licensing revenue stream on a on-demand one, on a demand business model. So that's one other barrier that I think hinders the deployment of HPC.
So if we take your point, then if we talk about HPC, we know that there are these exascale, petascale class applications, and then there is HPC for the small man, for the average man, so to say. So what you're telling me is cloud HPC on the cloud more for the average HPC user than for the exascale users?
You know, cloud has different aspects, right? One is the outsourcing aspect of IT. The other is the federation aspect of resources. Certainly, because of lowering the access, right, or the barrier to access computational resources, the small and medium companies are the first categories that will take advantage of this new deployment mechanism, right? And certainly in this area, we have already experience in our company with our first clouds offering for HPC with these small and medium companies that want immediate access to technology, to simulation for the engineering projects. However, if you go higher, let's say the scalability chain to the exascale applications. Well, by the way, there are no exascale applications yet, not even petascale applications. Right? Let's say thousands of cores used in a job, let's say in a computational job. There, the companies that have access to such machines, they have already enough on-premise resources. So there is maybe another aspect of value of cloud for cloud bursting. So I have a large data center, but large data center means it's never enough for the rapid growth in needs. So sometimes they look at cloud for cloud bursting as a very useful capability to have in a company.
Mm-hmm. Dan, you were mentioning the cultural and social barriers here. If we talk about cloud as an entrance for HPC customers in the future, shouldn't that be easier than to get this to the people? It's not the typical HPC centers, but Christian says it's the average person who would want to use HPC on the cloud.
I think so. In high performance computing for the last decade, we've talked about the excluded middle, that valley of death between the desktop and small parallelism users and the folks who really use at the high end. I think one of the opportunities for clouds, in the spirit of ISV codes and other simplicity where one accelerates high-level toolkits into the cloud, creates the illusion that the desktop has arbitrarily great, within some bounds, performance and capability, will bring in a lot of people. There are these cultural issues. I think there's one other thing to think about as we think about the complexity of multidisciplinary applications. That's another place where the larger scale research enterprises and companies come into play, and that's federation. Because increasingly, those groups want to share data in common tasks, and the ability to host that commonly creates another advantage. I guess one other thing I would say is we instinctively equate high-performance computing with floating point operations, and increasingly a lot of high-performance computing is about really large-scale data analytics, and that's a different model than just the MPI model, and I think that will bring in another set of users as well.
But big data is, of course, also a problem, especially also what you said, Josh, in performance. Getting the data into the cloud might be a difficult issue because we don't have the bandwidth today, or do we?
Well, I think there are three different approaches you could take there. So one would be that you actually generate the data in the cloud and it lives there, so it never had to get transferred there. Or you transfer it once and then amortize that transfer over lots of uses. So for example, what both Amazon and I believe Microsoft are doing with the hosting of public data sets in the cloud actually attracts communities of practice. So for example, the life sciences community can now go to Amazon and access large data sets that are resident in the cloud. And then the third one is the hard issue of the bandwidth and actually moving it in and out of the cloud. All three of those, I think, need to be looked at as options.
Mm-hmm. I would say, though, in that spirit, if we think about all of our other HPC facilities, we have those same large-scale bandwidth issues for them. The rate of data growth has vastly outstripped the performance of the wide area networks that we deployed at nation scale for research purposes as well. So it's a challenge on both sides, the bandwidth.
But I think that's a great point that you bring up. And for the HPC community, clouds are not a foreign idea. It's remote computing, right? And with the large scalable shared resources that the HPC community has deployed since the 80s, it at some level is very, very familiar, both from a technical perspective and also from a cultural perspective, as you were talking about earlier. So in some sense, the HPC community should be more poised to be accepting of a cloud environment, I think, than the typical enterprise, which may have more concerns. We'll see how that works out, but.
Well, the other concern, I mean, you brought a very good point, Joshua. One other inhibitor that I observed with some customers, it's the reluctance to give up to their data. It's not about data itself, because any one of us is using cloud in a way or the other. And my emails, my data, my credit card information, our online banking are already in the cloud, right? It's a cloud, if we want it or not. The problem is losing control, right? So this for technical computing, if you look at an automotive company or aerospace company, simulation is their business. Is a technology with which they generate they produce new products, better quality cars, safer cars or safer planes, right? While on the other functions, typical functions like email or customer relationship management, supply chain management, HR, are business supportive functions, so they're easier to deploy because I don't lose much if I'm in control. But in simulation, there is this kind of reluctance, right, of losing control of what's, for me, key technology and differentiator as a company.
So you all raised a number of points here, like security is one issue. We didn't talk about portability. You mentioned MPI. For clouds, we don't have something like MPI today, or do we?
Well, we do. So if you look at Amazon's recent offerings around GPU computing and just straight cluster computing, they do have an offering that is quite usable for MPI. We at VMware are looking very closely at RDMA as an underlying capability for enabling cloud infrastructure, not just for HPC, but we also see the use of a low latency, high bandwidth interconnect for a virtualization platform and for enterprise customers. So while it may not be totally possible at this point and there are technical issues to be dealt with, it definitely is coming. So we'll definitely see this.
Same thing's true at Microsoft, similar kinds of issues. I did want to go back to your exascale point, because I think there are actually some lessons that large-scale enterprise clouds can teach about the planning and R&D for exascale. Some about energy-efficient data center design at scale. Also some issues about how we think about resilience and reliability, because we certainly know the component counts will be a challenge at exascale, whatever technologies we use. There's a different hardware-software model in cloud data centers where they are designed to accommodate failure as a first-class activity. It's expected to happen, and that's largely been anathema to the way we think in HPC. Our checkpoint restart model is predicated on the notion that failure is a rare event. As we get bigger and bigger systems, failures are going to become more common, and there's some things we could learn from the cloud experience that would inform how we build some of these larger systems for technical computing.
Well, and Hadoop is a great example of that, right? So, or MapReduce, the fact that it has resiliency built into the platform. You don't code for the resiliency, it's just there. And they run that at 1,000 nodes or more. They're running at quite a high scale. That's totally about big data analytics in the enterprise, not in HPC use.
Thanks a lot, gentlemen. That seems you're optimistic about the future of HPC in the cloud. Thanks for your contribution.
That's quick.
No fist fights?